Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, on this part of this Mist series, what I'm going to be going through is again the service level expectations, or SLEs, but this time I'm going to be covering it for the WAN, or the wide area network. Now, for those of you who aren't familiar with what a WAN is, what a wide area network is, or SD-WAN, regardless, just think of it as your organization's connectivity to the internet, to those applications, to those databases that are hosted somewhere up there in the cloud. That's basically what a WAN is. And to provide that WAN connectivity, it might be going over the internet, or maybe it's going over some kind of cellular connection, or like 4G or 5G, or maybe you're using multi-protocol label switching, MPLS networks, etc, etc. There's obviously going to be some form, some means to get your traffic, your organization's traffic from your network to that destination and back again. And that's what the wide area network is actually providing. Now, if you don't know what Mist is, first and foremost, please check out this video. It's a part I did on this series, which basically describes what Mist actually is, where it is, and the benefits that it brings to any enterprise organization. But on this part, I will be going through those service level expectations, those 3 SLEs that you get in the Juniper Networks Mist solution for that wide area network, or WAN, and I'm just going to call it WAN moving forward. And what I'll do is I'll go through what are those 3 service level expectations, what are all those classifiers that you get for each one of those service level expectations, or SLEs, and in some cases what are those sub-classifiers, and really from a high level, what does all this data actually mean? What does all these classifiers and sub-classifiers actually mean, before going on to the user interface and showing on a demo system, of course, where that theory actually meets practice, and what does it actually look like in terms of having all of that AI data on that wide area network. So no more of me talking, let's actually just go straight into the theory and talk about those wide area network, or WAN, service level expectations. And here we go, let's start talking about those service level expectations, or SLEs, for that wide area network, for that WAN, or maybe for the SD-WAN. We're not going to go into the differences between WAN and SD-WAN and the technologies. That's not the focus for this. The focus is, of course, on these service level expectations, or SLEs, as I'm just going to call them now, he says. Typically, I always start calling them by their actual full name. But what is Juniper Mist? Let's first discuss what that is. Well, what Juniper Mist is, and apologies, that is my picture for a cloud, but Juniper Networks Mist solution for the enterprise networks is a cloud-based solution. So it's up there, hosted in the cloud, and then, of course, all the benefits around a cloud-based solution. Of course, we all know the story. But additional aspects that you do need to know is that it has AI-driven insights, so artificial intelligence. Now, AI is a huge buzzword these days, as I always say in all these videos, and it's absolutely true, because AI is just proven to resolve real-world problems. But the artificial intelligence, and there's different forms of AI on Juniper's Mist, the AI that's being used by Juniper Mist has actually got 7 different variations. There's several different forms of AI on Juniper's Mist. But via the insight, it's actually helping the enterprise network, regardless of industry or sector or vertical, it's helping them solve their real world problems, their real world networking problems, specifically on that wide area network, on the WAN itself. But also another point you need to be aware of is that it is built with microservices in mind. So a microservice, as I always say, it's a piece of a puzzle. It's a, if you've got 1,000-piece puzzle or 100-piece puzzle, it doesn't matter. Each one of those pieces of the puzzle represents a different service, represents a different function, represents a different piece of that picture, and the Mist microservice allows all these different microservices to form their different functions, but for each of them to actually be taken down to be updated, to have maintenance performed, and yet this whole solution just remains available 24/7 and of course 365 days a year. It's never gone down because of those microservices, and typically because of that you see Juniper's Mist doing a whole new batch of firmware updates, feature updates every few weeks. Not firmware updates, let's talk about hardware, but feature updates for the solution itself. And in fact, as of today, the day I'm doing this video, which is 20th of May 2024, there was a huge release of features, which is very exciting. But let's bring it back to these service level expectations. So you've got Mist. Mist is just up there in the cloud. And then you've got your enterprise network. So I'm just going to draw right here a box to represent that enterprise network. So just call it Enterprise A, for example. Doesn't matter. Now, right at the bottom, you of course got ourselves. You've got the users, you've got your mobile phones, you've got the tablets, maybe you've got till points if you talk about retail, or maybe some kind of computer check-in if it's a hotel, etc., etc. It really doesn't matter. Or maybe it's, as another example, or maybe it's a server if we talk about campus fabric. But typically for most of these clients, they are connecting to the network via some form of Wi-Fi standard. So that could be Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, 6E, etc. And for Juniper Networks, this is called the Mist access point here. Now, for the service level expectations for the access points, this actually falls under wireless assurance. And I've already done a video on what wireless assurance is and all those SLEs, those 7 SLEs that fall within wireless assurance. If you haven't seen that video, here's a link, please check it out. But what it's doing is it's giving the insights, those deep insights, using AI into all those clients, devices, etc. that are connecting to that wireless network, to that Wi-Fi network. But of course, the reality is you're not going to have an AP connecting straight to the internet. Of course, you're then going to have some kind of switching estate. So we're going to have access switches, maybe distribution switches, and right at the top here, I'm only going to do the one, maybe a core switch. So I'm just going to do core, distribution, and access layer switches here, CDA respectively. And of course, in an ideal world, they'll have cross connectivity to and from each other to allow for load balancing, resiliency, multipath, talking about BGP for campus fabric, etc., etc. So maybe this server here was actually not connecting to the network via a Wi-Fi protocol, a Wi-Fi standard. Maybe it had a direct connection, maybe even multi-homed connection into that switching network itself. Now from Juniper's Mist, the switching estate that you see here from the core all the way down to the access layer, and obviously there's different variations of switch types, of course, this falls into the wired assurance. And again, just like with the wireless assurance, if you don't know what wired assurance is, please check out this link. It's the last video I've done, the last part of this series. So it's all described there in terms of those different 3 service level expectations. There we go, I said the full name, the 3 SOEs. But again, what wired assurance is doing is it's giving the insights into that switching estate and all those wired clients connected to it, whether it be an AP or an actual device itself. But obviously, when we start moving towards the edge of the network, you're then going to have your wide area network. So WAN router here. Now from Juniper, there is either a session smart router, which is utilizing traditional ways like IPsec tunnels, but also it utilizes a more standard approach, a more updated modern approach called secure vector routing, or SVR. And also then there's the traditional appliances like the SRX firewalls to do the IPsec tunneling. So different approaches to provide that WAN and SD-WAN connectivity, but very much different use cases between the two. And guess what? For those session smart routers, for those SRX devices that are providing that WAN-SD-WAN connectivity, this falls under, guess what? WAN assurance. And that is what basically WAN assurance is it's providing the AI insights, the deep insights via AI. And why is that important? Well, let's bring it back to ourselves. Let's bring it back to the end user. So end user here, or your phone, tablet, till point, hotel check-in service, your bare metal server, your campus fabric server, etc., etc. Whatever the client is, it really doesn't matter. But obviously they are generating some type of traffic. They're generating and utilizing some type of service across your enterprise networking estate, across the Wi-Fi network, across the switching network, all the way maybe up to the WAN itself. And all those applications and services are really trying to utilize some type of application. And let's put this into reality. What types of applications are hosted that enterprises use that are hosted on the cloud today? Well, a typical one, and I use this for my work, is Microsoft Teams. Other organizations will use maybe Zoom. Zoom absolutely exploded during COVID times. Don't like to talk about that because that wasn't fun for anyone. But those are just two examples of cloud-based services. Or maybe you're utilizing some kind of monitoring application such as Splunk. Or maybe the organization has their own custom application that they're also hosting in the cloud, etc., etc. Needless to say, there's X amount of applications that are hosted in the cloud itself. And what the WAN Assurance is doing is it's giving the deep insights through artificial intelligence into the applications themselves. But not only that, it's also giving the applications into that WAN router, into that device, even into that interface. And so there are three very important distinguishers. And this is coming back to those three service level expectations. Is one area of WAN assurance is we're looking at the device, we're looking at the WAN router, we're looking at seeing how is it operating, is it healthy, is the CPU health, etc. too high, I don't want to go too fast too quick. The other area is on the WAN connection, on the WAN interface, so that interface that is connecting to the cloud itself. What's the general health of that WAN link? And then of course the third part is the applications that are going over that WAN, going over the SD-WAN. What's the health like of those applications? And I've just tidied up the screen just a little bit, but as I was saying, all these devices, regardless of the device type, more than often they are accessing some kind of cloud-based application, more than likely. And as such, you've got all that traffic going across that enterprise network, and I forgot to write enterprise A here, so let me just do that, enterprise A, to where it gets to the WAN itself. Now let's say here that SaaS service, that SaaS-based application is up here in a different cloud, and let's just say it's Microsoft Teams. Let's just keep it simple, let's keep it very high level. Now, how is that traffic going to get from enterprise A to wherever that Microsoft Teams application is actually hosted? And this comes back to what I was saying, where maybe your organization is using the internet to get to that SaaS-based application. Or maybe you're utilizing a service provider's multi-protocol label switching network, and it's a big topic of discussion these days. Or maybe you're using some kind of cell network to get to that SaaS-based application. Or maybe you're just using broadband to get there as well. Whatever it may be, and let's just say enterprise A is utilizing both the internet and multi-protocol label switching to get to that SaaS-based application. Maybe they're using MPLS as primary and the internet as backup. So if this connection goes down or something happens in the MPLS network, then they've always got a backup link here. And that's just generally the beauty of an SD-WAN network. But coming back to WAN assurance, those SLEs, again, those service level expectations are one, providing a service level expectation on the device itself, on that WAN router. Two, is providing an SLE on the connection. I'll just try and draw it here, on a connection that's connecting your enterprise, the enterprise network, to the internet, to the MPLS, to the cloud basically. And three, it's then monitoring, I'm just going to draw it this way, it's monitoring the application going through that SD-WAN, that WAN router itself, and seeing what's the uptime, what's the packet loss, what's the jitter, etc. So again, high level, those are those 3 service level expectations, or SLEs. But let's draw them out. So let's do number 1, and this is actually called WAN Edge Health. And as the name implies, it's about the health of that WAN router. And I'm going to leave a space here deliberately. The second classifier is WAN Link Health. So this is moving away from the WAN router itself, but now we're looking at the link that's connecting that enterprise network to the bigger world, to the internet, to that primary link, multi-protocol label switching, to that MPLS network in this case. And the third classifier, so the third SLE, is application, and I'm just going to do app for short, app health itself. So for that WAN Assurance subscription, obviously it's a subscription based, you are getting the 3 SLEs, which is your WAN Edge Health, your WAN Link Health, and the application health itself. Now, all of this sounds straightforward in the context of, well, you're getting all of this data up to the Mist cloud, and as we know, it's using AI and microservices, etc. But one of the things I mentioned in a previous video is the amount of data that's coming from the network into the Mist cloud. It's a lot, to say the least. For example, for those wireless devices connecting to those access points, over 150 states of telemetry could be sent up, depends if there's any state changes, but could be sent up to the Mist cloud every minute for every device that is connected. And it's no different, regardless of numbers, it's no different in regards to concept, to the switching estate, and of course to this WAN estate as well, to your WAN-SD-WAN routers. And AI needs a lot of data to do its computation and to solve those real world problems. So that is the function of these SLEs, is they're taking all that AI data and getting rid of the white noise and simplifying it so any user can see, well, in this case, what's happening on the wide area network. So if users are experiencing an issue on your wireless network, but wireless assurance is saying there's nothing wrong with Wi-Fi interference or non-Wi-Fi interference or congestion or time to connect, etc., etc., everything looks good, and your switching estate looks good, then that obviously points a finger to the WAN. But enterprise wants to, of course, have the knowledge to say it's not my wide area network, it's not the WAN router itself, it's not the link to my service provider, and it's not the applications that are going through my network, it's something that's outside of my network and then approach that service provider. And yeah, a little bit of finger pointing goes on there, of course, but that's just the nature of networking. But at least then that enterprise network has got that lowest mean time to resolution and can actually identify if this problem is inside of their network or outside of their network. But coming back to these 3 SLEs, is what the Mist WAN Assurance is then doing, is then providing what is called classifiers to classify out all of that data. So again, AI needs a huge amount of data, and the classifiers are defining if there is a problem on the WAN, speaking very generically I know, but if there's a problem on the WAN, what is that problem, who's it impacting, why is it impacting them, and of course then get some insight into how to resolve those issues. And for some of these you then have sub-classifiers as well. Now, you don't have a sub-classifier for every classifier, but if you look at it in regards to DHCP, DHCP is not on the WAN assurance as well, just for full information there, for full disclosure. But if you look at DHCP, where you've got a packet going out from client to server and packets coming in, you've got your discover, your offer, your request, your acknowledgement, and maybe a few other packets. It's a big process, but DHCP just generally works. But the sub-classifier here would say and identify where in that process between client and server did that fault, did that problem, did that error actually occur? Was it between client and server or server to client? Was it on the discover message, or was that DHCP server completely unreachable? Etc, etc. So the sub-classifiers are basically giving more context into these classifiers, but again, it's not there for all of them because you don't need sub-classifiers for some of these classifiers, as you're going to see right now. And let's take that a step further. So if we look at the WAN edge health here, this is obviously looking at that WAN router itself. What is it like? Is it okay? Is it healthy? And the classifiers for this are power, CPU, memory. There's a big one called WAN edge disconnected. And the last one is temperature. So the power really speaks for itself. Has that WAN router got enough power or not enough power? CPU, is the CPU spiking? Is it getting close to 100%? And if so, that's obviously going to cause some problems. Is the memory running out on the SOX or on the SSR? The WAN edge disconnected is about, has that WAN router actually disconnected, not from the network, but from Mist? Has it done some kind of upgrade or someone changed the configuration and Mist has just lost visibility? It's still past traffic, but has it lost visibility to that device? And for temperature, this actually has two sub-classifiers. There's a temperature which actually monitors the temperature on the chassis itself, and another sub-classifier which measures the temperature on the CPU. So if your CPU is spiking just once for a second, that's not going to increase the temperature. But if it's running at nearly 100% for hours or days, that's going to increase the temperature under the CPU for the temperature classifier. And that's, of course, going to have problems on the WAN router itself. And, of course, all the traffic and applications that's going in and out of that device. And when you look at the WAN link health, this is, of course, looking at the health, the general condition stability of that WAN connection. There's only two classifiers, which is network and interface. Now the network is where it's referring to traditional concepts like jitter and latency. So you can measure in milliseconds the jitter and latency that's going out of your network for all of those applications. And at the interface layer, there's quite a few sub-classifiers. Or actually there's a third one for network. It's actually, the third one is IPsec down or IPsec tunnel down. So if you have IPsec tunnels running from enterprise A to enterprise B via hub, you've got an IPsec tunnel, and this is measuring the health of the IPsec tunnel, which is a virtual link at the end of the day. But for interface, you can measure, are there any cable issues? Is there any congestion on that uplink to whatever's connecting enterprise A to the network? So here you'd have some kind of router, and here is there any congestion on the uplink to that provider edge router here, or custom edge router actually, and VPN. So we're also going to see what's the interface health of that VPN tunnel as well. So here we're looking at the IPsec tunnel, is it up or has it gone down? And here we're looking at, is the VPN tunnel actually established? And the third classifier, application health. Good news is that there's no sub-classifiers. There is loss, so packet loss, latency, and of course jitter or packet delay variation. So those are the three service level expectations, so three SLEs that you get for that WAN assurance license. And what those classifiers are doing for each one of those SLEs is they're classifying out more context, they're classifying out more meaning. So when you've got all of this data from your enterprise up to the Mist cloud and it goes through the AI engine, the classifiers are going to give meaning, they're going to give substance to all of that data. So if the WAN router is running at a high CPU, that's obviously going to be impacting all of these devices' applications going across and in and out of that network. But if it's running at a high CPU, the Mist will say this is running at a high CPU, this is how long it's been running at a high CPU for, but most importantly, this is why it's running at a high CPU. It's downloading a constant amount of feature updates or firmware updates, or maybe someone's doing an upgrade in the firmware itself, or maybe just the control plane and data plane, or the control plane dash data plane is just experiencing a high volume of traffic. Maybe someone, and I've seen this, is downloading a huge amount of file information, and I don't just mean 1 or 2 gigabytes, I mean tens and tens of gigabyte, which causes CPU spikes, and of course, coming back to another classifier, congestion on that WAN as well. So this is where the AI gives context into all of that data, and this is why SOEs are defining in here the 3 categories as to the WAN router itself, the connection on the WAN router, and the application that's going over the WAN router, over that link, over that connection. But then the classifiers are adding that context, that substance, that meaning into what does that data actually mean, and where do you need to go to really resolve those real world problems. And so let's start looking at the user interface on the Mist solution, of course, for the WAN service level expectations, the SLEs. So when you log on to the Juniper Mist, where can you actually find all those SLEs? Well, it's underneath the monitor tab, as I call it, the monitor selection just here. And as you can see, we've got the wireless field, we've also got the wired field, and then the WAN field as well. So obviously the wireless field is for Wi-Fi, the wired field is for your switching, and the WAN field, I'll just write it over here, is of course for, guess what, that WAN-SD-WAN network, the connectivity. And right here is where you can actually define, and I'll show this just in a minute's time, is where you can actually define that client to cloud visibility. So you can select a particular site. So whether you've got 1 site, 10 sites, 100 sites for Mist, it doesn't matter. You can filter down onto a particular site within that organization, or have an organization wide view, i.e. that single pane of glass, or you can select a particular WAN router itself. And then you can also define a time period to get all of this data actually in. So as you can see, it's actually just predefined to be 7 days, but you could do 24 hours or a custom period or the last 24 hours, 48 hours, etc., etc. You get the point. But to be clear, what is the SLE? Well, the SLE, and the E really gives it away because that's referring to the service level expectation. And the expectation is the giveaway. It's the big word that you need to focus on. You define, if you are that network operator, you're the administrator for this WAN-SD-WAN, you are defining what you expect for your network, what you expect in terms of connectivity and experience. So for the WAN edge health and for the WAN link health and for the application health, what are your expectations? How do you want the end users to be connected? What do you expect for them in terms of their experience? And this is actually defined in the settings tab here. And so let's just go into that settings tab. So here you can actually see, and I don't have the privileges, the rights, the settings to actually change the expectation. But by going into each one of this WAN edge health, and I don't actually think you define an expectation because typically you always want your WAN routers, your Wi-Fi APs, your EX-QFX switches for the wired part, you want them to be operating at 100% health. So it doesn't really make sense to define an expectation on that side. But for the WAN link health and for the application and the application health more specifically, you would define in milliseconds, as you're seeing here, what do you expect. So if there was, say for example, a expectation of 80 milliseconds just here, so I'm just going to try and draw 80 milliseconds, then any traffic that falls below that expectation is going to be great. It's going to be within your expectation. But any traffic that goes above that 80 milliseconds expectation, it's not going to fail, of course, but it's going to be earmarked. It's going to be shown as an area of concern. And thus, just down here, you could just see it in the background. You'd actually then see all that traffic, all those applications that are failing that actual 80 millisecond, for example, marker. But let's close this now. And what you can also see is this little drop down here. And this is great because here you can actually define all the system changes. And this is very important because we're talking about a wide area network. We're talking about connecting that enterprise A, going back to the previous part, we're talking about connecting that enterprise to the global network, to the internet, to the multi-protocol label switching, maybe to cell, maybe to broadband, whatever it is, it really doesn't matter in terms of that transportation method to get from A to B, wherever B actually is. But there's a WAN-SD-WAN connection, and there's a lot of protocols that you can use. Typically BGP is used. So if the BGP peering is going down or up, or if the state's actually changed, that's actually going to be shown on the timeline on the back here. And the same for OSPF. Note there's no ISIS there, because ISIS, or intermediate system to intermediate system, is really more for the service provider networks. It's not really applicable and relevant and seen at all, I would say, from my experience, in the enterprise network. And just to show, under the site here is where you define or you select, do you want to have that entire org-wide view, i.e. that single pane of glass? And you can actually then just see the worst 100 sites by the WAN edge health, and you can then see the worst 100 sites by application health. Or you can drill down to a particular site, as we just saw, or even down to a particular WAN router here. So just for this site live demo, there's only the one, so let me just pick a random one, and there's another WAN router here. Or let's just go back to that site itself. And so there we go, I've just done a quick view there. So the big giveaway there, the big point there is if you want to view the WAN SLEs, those expectations and what traffic is failing to meet that expectation, it's under monitor, service levels, WAN, select your site or org or WAN router and define the period. And then you're going to see all this data here. And all this data is coming from the network. So we've got the 3 service level expectations as I define: the WAN edge health, all about the health of the WAN router; the WAN link health, which is between the enterprise, you've got a link going to, just for example, your service provider. So this is about the interface that is right here. And for the application health, which is all the applications which are going over that WAN router as well. But what you can see here is all those classifiers here for each one of those SLEs, each one of those service level expectations. And I defined this in the last one, I'm not going to go through it again, but here you can actually see all of those classifiers. And by selecting some of them, you will then see the sub-classifiers. Well, what does this page actually mean? What are we looking at? Well, of course, we're looking at the WAN results. We're looking at the WAN experience on that enterprise. In this particular case, the site live demo for the last 7 days. And you can see the WAN edge health is really good. It's around about, or just greater than 99%. Oh, sorry, just less than 99%. And what you can then see on the right-hand side under the classifiers is we're missing, just let's be simple here, we're missing 1%. It's only at 99% or thereabouts. What we're then doing, what Mist is showing, is that missing 1% has been caused by CPU. So the CPU had a bit of a hit. No other classifiers were showing any percentages there. You could see they're all at 0%. But the CPU is showing 100%. That doesn't mean it was running at 100%. It means that this missing 1% of this 99%, 100% of that was caused by CPU. And it's the same for the WAN link health. So just less than 99% and 100% of that missing 1% was due to networking issues. We'll go into that in just a second. But the big point here, the big SOE to actually look at, the part that's failing that organizations, that enterprises' expectations, is the application health. It's only at 77%. And again, what Mist is doing, using all the data for all the connected users that are coming into the network and connected to the network, is to say, well, what's happened to this missing 23%? And again, that's where the classifiers come in. And you can see for latency, it was at 65%. For jitter, it was at 35%, and there was no packet loss. So just there, immediately, you can see how the WAN network is actually performing. The WAN edge health is really, really good. A little bit of CPU, but nothing to be concerned about. The WAN link health is very, very good. A little bit of a hit there due to networking issues. We'll go on to that, but nothing to be concerned about. But the application health could obviously be better. So first and foremost, it's going to this WAN link health. So let's just select WAN link health, that SLE, and you can now just see general statistics. So statistics is 99% on average was at 1.3 megabits per second. But if I actually select the network, because don't forget that missing 1% was due to network, and if I now select network, we can now see those sub-classifiers really define, give more context, more substance, more meaning into what does that network 100% actually mean. And this is absolutely the power of AI data, because we've got just about 1% missing here. And that missing 1%, 100% of that is caused to network. But now the AI Mist is giving us the insights into, well, out of this 100%, that is further split down into jitter. So 64% of that 100% of that missing 1% was due to jitter on the link itself. And a further 36% of that was due to latency on the network, on the link itself. Now, jitter and latency are obviously unavoidable in any network. You're always going to get some jitter and some latency, of course. Jitter wants to be as minimal as possible for real-time services. And I don't want to go into basic networking, but for real-time services, minimal jitter as possible. But for non-real-time services, jitter doesn't really matter as long as the traffic actually gets there. But if I now select jitter, we can see that this impacted, the jitter was at 64% of that 100% of that missing 1% of that WAN link health. But this has impacted 192 user minutes. And the user minutes is quite literally the impact of users and their minutes of experience over the network. So let's just say for example, you've got 60 users and each of them is utilizing 4 minutes of network availability, 4 minutes of your network. So that is obviously then 240 user minutes. Simple maths, of course. Now, what the jitter showed here is that it was around about 192 minutes. Now, what that means in context is that out of a total 240 minutes, user minutes, for those 60 users, 192, just for example, 192 of those minutes was impacted by jitter. And this is important because not a lot of people know how to measure jitter. Not a lot of organizations actually define what is acceptable jitter on their network. So it does raise the questions around, okay, what's good, what's bad, what should I deem as acceptable when it comes to jitter or even latency and packet loss on my network. And so, yeah, it's a bit of a vague area. And that's why we've got this concept, why Juniper Mist has got this concept of user minutes, because it's adding context to what all of that data actually means. So as I was showing and I was right, it means 192 user minutes was impacted. Now you can change this from percentage to actually a number. So this is 192 0 minutes here and 109 user minutes here out of a possible 301 user minutes. Okay, good. So, well, it's not good, but it is actually good because in fairness, if I bring this back to percentage, it's around 99%, which means it's blooming really good, to be honest. But still, using the AI insights, Mist can say, well, that missing 1% or thereabout, just to summarize, was caused by networking issues, which is mostly due to jitter, but there was some latency which impacted 109 user minutes as well. Now under distribution is where Mist will show how is that jitter, because I've got jitter selected here, how is that jitter distributed across the network. So you can actually see what clients experienced that jitter, what was the overall impact, how much did they contribute, and you can see there's quite a lot here, quite a lot of users, how much did they actually contribute to that 64%. Now the big one here is the anomaly. What AI is doing is it's baselining what's normal behavior, what's normal for that network in terms of jitter, in terms of latency, in terms of application health, etc., etc. And anything that falls outside of that expectation that the administrator defines, either SLE, is then marked as an anomaly. So if it's 1.00x plus, it means there's an anomaly. It means something's been seen by Mist through the AI and flagged it as an anomaly. So when you see something like 44.25, that means that it's a considerably high anomaly. So as you can see, it's only been responsible for 2% of those failures and failed 4% of the actual time, but it failed to meet that service level goal, that SLE, 44.25 times more than normal, more than average. You can also see under applications what applications are failing to meet that SLE. So on over the WAN link health, that missing 1%, what applications have been impacted by that jitter? What are the WAN edges? So we can actually see that WAN-SD-WAN router and the interfaces connected to it. Now, of course, I can select this and go into detail into that WAN device itself. You can now see we're viewing the insights for this particular SRX. But I'm just going to hit back because I don't actually want to go there just yet. But let's actually go onto the main contributor here, the application health. So as we can see, there's 23% actually missing for the application health. And as before, this missing 23% here, the classifiers are classifying out what's happened to that missing 23%. So 65% of that is caused by latency. 0% of that is caused by loss, but 35% of that is caused by jitter. Now the difference being is the WAN link health was looking at that connection on that WAN router, which was going over to that service provider. But then you've got applications which are going back and forth over that link itself. And that's what the application health is actually looking at here. So obviously latency is the biggest contributor to that missing 23%. So let's click latency, and now you can see the actual milliseconds of latency that has been learned for those applications that are passing over that WAN link, over that connection, obviously on those applications. So the total value for latency was 276.9 milliseconds. I can tell you now that is incredibly high. You do not want that for real-time services, and even non-real-time services is going to feel like there's this lag there. But again, maybe for some organizations you define that to be an acceptable expectation, each to their own. But we can see that the latency has contributed the most. And again, under timeline, we could see when those milliseconds have actually occurred. And that's important because right at the bottom here, you can see system changes, and we can see when the latency was actually seen in terms of going above the baseline, being an anomaly, going above your expectation that you've defined as part of the SLE. But you can also see what were the number of connected users. So at that particular time, when there was this latency, total latency being seen, there was 83 clients actually connected. And you can also see, again, under distribution is more of the network insight. So we can see where all of that latency was distributed across the network in terms of the zones, the security zones, the WAN edges themselves, only for this particular SRX switching device, firewall device, and routing device that the latency was actually seen on. And of course the interfaces. And under the affected items is where you can actually view what applications failed to meet the application health SLE. So really only one, Microsoft Teams. And of course you could click on here and you can see the specific application health for the Microsoft Teams. So during that time period, it experienced 79 milliseconds of latency for the application. But you can also see again interfaces, the clients that were using this particular application going over that WAN, and the WAN edges, and what the queues, no affected queues currently. But let's actually go into view insights. And right at the top here you can see for this particular site for the last 7 days, so we're viewing at a site level all of those insights. And if I keep scrolling down, you can see the Marvis Minis, test fails, test passes. I'll go into Marvis Minis in a future video. You can see the client events. So there's quite a lot here in total and quite a lot of bad. So you can see some authorization failures and deauthentication. There's quite a lot going on here. And if I keep going down, you can see the AP events within that particular site, but also all the applications that were being used that weren't necessarily impacted by that latency, that weren't necessarily breaching your SOE, your expectation. But you could see that there is an unknown traffic, an unknown application, so it's probably encrypted, and it's using a hell of a lot of information, a hell of a lot of bandwidth. And there's 101 clients, and you can find out who just by selecting that 101 here. And you can see all the names and MAC addresses of these devices that are using or that particular application, whatever it is, maybe do some investigation. But we can see CNN, Yahoo, Apple, Vimeo, Video, Juniper VPN for obvious reasons, etc., etc. And if I keep scrolling down, then you can get the Microsoft Teams insights. So just by selecting a particular area, and I'm just going to do here, that application health failed for Microsoft Teams, where it was a very, very high latency value. I can't remember exactly why it was. But now we can actually get the Microsoft Teams insights on the WAN Edge itself for that particular site. And you can actually see what was the audio like, what was the video like, what was the screen sharing like, what was the WAN average latency during that period. And you can actually see just here, and I'm not moving the mouse deliberately, but you can see that WAN average latency under the latency graph. The average latency across the WAN was 227 milliseconds. And that did have an impact on the audio, on the video. And this is important because it's all about correlation. It's all about correlating all of this information together. And what you can go back up and actually see is that, yeah, at the same time, that's the reason why I pointed out there was a lot of traffic, a lot of bandwidth being used by this unknown application and by CNN and by not so much Yahoo, but typically these two applications, well over 300 gigabyte of bandwidth actually being used. And that's going to impact the availability of that bandwidth over the WAN connection. It's just a consolidation, it's correlation of all the information together. And scrolling further down, you can see the DNS latency, the DHCP latency. Maybe it peaked. You can see some particular spikes here. Maybe that's due to the WAN link being saturated by all those applications and current wireless LANs and access points. A lot of information to say the least, and even the wired switches under this particular site itself. But just there, in short, very quickly, what I managed to do was go from a WAN level view for the site, live demo for 7 days, and actually see, well, what's happened to this missing 23%. And by selecting here and going into the actual latency and under distribution, as I can see who was being impacted by this from a networking perspective, from the network itself. And what were the affected items being the application itself? What clients were actually using those applications? What clients were impacted by this latency and over what interfaces? But when I went into the Microsoft Teams, I could see specifically the latency for that Microsoft Teams as I showed here. But really under the view insights is where I got that correlation, where Mist correlates it all together. And you can just see, yeah, there's some good and bad events for clients, and there's the AP events are all really good. But just here you could see a lot of traffic, in summary again, has been really utilized. Bandwidth has been utilized by these two applications, by these 105 clients, and that has impacted the Microsoft Teams. So a lot of organizations use Microsoft Teams these days for work purposes, and users will typically comment or complain when the video's choppy, when there's this lag or there's pixels missing, etc. And this is given the correlation of information together. So Mist will tell that troubleshooting team, that network operations team, etc., etc. Well, these users are complaining because all these other users on the network have been downloading a huge amount of traffic. One for CNN, a lot of news going on, and one for this unknown application, and then do investigation into, well, what the hell were you actually accessing in the first place to use over 200 gigabyte of bandwidth? And so there we go, everybody. That is the end of this video. That is the end of this part. We've gone into those WAN, I'm going to say it, those wide area network SOEs, the service level expectations. As always, I hope you found that useful. I hope you found that informative. I promise you there's a lot more content that's coming. There's just been the Mobility Field Day 11 where Juniper Networks, the Mist team, have announced a whole new batch of feature updates. And just yesterday, the 20th of May 2024, when I started this video, there was a whole new batch of features that were released on the Mist cloud. So a lot more content to come. But back to this part, we saw and went through what are the service level expectations. So 3 SLEs, from the WAN Edge Health to the WAN link health, and to the application health as well. And what does an SLE, a service level expectation, actually mean? I.e., that operations team defines what's their expectation for users connecting to the network. What's their expectation in terms of experience? And as we actually saw, we were able to go into those SLEs, into those classifiers, and in some cases those subclassifiers, and drill down into all of that information and see how is that latency, that jitter distributed across the network, distributed across the applications, distributed across the clients, and how much did they experience that anomaly, experience that latency and jitter. And by going into the view insights, do that correlation of, okay, there was Microsoft Teams being impacted by latency, but why was it impacted? And as we saw, it was because of all those users were using a lot of bandwidth on the WAN. So that is Juniper Mist's WAN SLEs, the WAN insights. As always, if you have any questions or comments, let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.